Let's consider the properties of these six quadrilaterals. So quadrilaterals are four-sided shapes. And the question is, what makes these shapes, I guess, what makes them different to any other shape? And I guess what makes a trapezium, what makes a kite, what makes a parallelogram. Okay, so it's really looking at those certain properties that really make the shape what it is and why we call it, the name that we call it. Starting off with the trapezium, okay, so I might just draw just a sketch of it here. A trapezium, there's only one thing that we need to know about a trapezium, apart from having four sides. There has to be one pair of parallel sides, and that's it. So as long as there's one pair of parallel sides, it's a trapezium, and that's good enough. There is a couple of other little properties, though, that are well worth noting. Because these are parallel lines, let's say, for example, if this was, say, 60 degrees, okay, this angle here, okay, what would be the relationship of this angle here, okay, this angle there, to the 60 degrees, okay, and that relationship would be a co-interior relationship. If you remember, co-interior angles, basically they sit inside a pair of parallel lines. They can also sit on the outside too, but in this instance, they sit on the inside, and co-interior angles add up to 180 degrees. Okay, so that's a trapezium. Okay, a kite. So a kite would look something like so. And it's got a bit of a tail. Okay, so there's a kite, and I'll just draw in the diagonals. Okay, and first of all, the diagonals intersect at 90 degrees, and the long diagonal actually cuts the shorter diagonal in half. Okay, so those two, the short diagonal there is cut perfectly in half by the longer diagonal. Also, the adjacent sides are equal to each other. Okay, so we use these markings, these little dashes there, to indicate which sides are equal to each other. So this side here is equal to this side there. This side is equal to this side. They're called adjacent sides because the sides are next to each other. Okay, they're different to opposite sides, for example. Okay, let's moving on to parallelogram. Okay, and a parallelogram is sort of looks like that. Okay. And parallelogram has two pairs of parallel sides. Okay, the opposite sides are parallel to each other, so we have two pairs. And also, opposite sides are equal in length as well. So this side and this side are equal to each other. This side and this side are equal to each other. Also, another interesting property with parallelograms is opposite angles are equal to each other. So if that's angle A degrees, this one here is also A degrees. Okay. If this is B degrees there, this one here is also B degrees there. And also, just like the trapezium, because A and B sit inside a pair of parallel lines, okay, you have that C shape there, A and B are co-interior to each other. Okay, so a parallelogram behaves a lot like a trapezium in that sense. All right, and the other thing as well with parallelograms is that their diagonals bisect each other. Okay, so I might just redraw it. Okay, so alright, and okay, so that is equal to that, and that is equal to that. Alright, so there's two each diagonal bisects each other in half. The angles that are formed by the diagonals, though, are not 90 degrees. Okay, it's something else, but they're not 90. All right, so that's a parallelogram. All right, let's have a look at a rhombus. Okay, so a rhombus looks a bit like a parallelogram. The only difference being is that all sides are in fact equal to each other, and again, opposite sides are parallel as well. So top and the bottom sides are equal and parallel, and the two sides, the left and the right hand side, are equal and parallel as well. So it's a bit like a square in that sense, that the sides are equal, but they're not 90 degree angles inside. Okay, so if I draw in the diagonals, it also looks a bit like a kite too. Okay, if I was to turn it like that, all right, you can see that it's almost like a kite shape. The one unique property of the rhombus is that the diagonals bisect each other at 90 degrees. In fact, so that each diagonal cuts the other diagonal perfectly in half. Okay, so you end up with sort of nice, neat 4 identical right-angled triangles. In fact, so 1, 2, 3, 4, and sort of identical to each other. So that's a rhombus. So in that sense, a rhombus shares very similar properties to a parallelogram, which also have inherit some properties from a trapezium as well. Okay, most certainly a trapezium's diagonals do not bisect each other necessarily, but if the question was asked that is a parallelogram a type of trapezium, then based on the fact that a parallelogram does have one pair of parallel sides, or at least one pair of parallel sides, a parallelogram could be argued that it's a type of trapezium, a very special type of trapezium. But a trapezium is most certainly not a parallelogram. Okay, so it's very important that we make that clear. Let's have a look at a rectangle and sort of the all popular rectangle, which we know and love, and we've seen that all too often, from very early days of maths and when we first learn about shapes. Rectangles again have opposite sides equal to each other. They also have opposite sides parallel to each other too. Okay, and what other shape has this property? Okay, rectangles are very similar to parallelograms. And if we looked at parallelograms, they have a very similar set of properties. Now, one thing with rectangles though, the diagonals of a rectangle bisect each other, but the diagonals are actually equal in length. So in fact, the diagonals bisect each other and the diagonals are also equal in length as well. Okay, maybe I should put three bars there because I've used up the 2 there. And that's a rectangle. Okay, and also be mindful that the angles inside a rectangle, the internal angles, are all 90 degrees as well. Whereby with a parallelogram and a rhombus, they're not. Okay, so parallelogram, once you sort of straighten out the sides and you can turn it into a rectangle. Is a rectangle then a type of parallelogram? In fact, yes it is. A rectangle is a very special type of parallelogram, but a parallelogram is not a rectangle. Okay, so we've got to be careful how we, how we classify these shapes. And lastly, we'll have a look at a square. We know what a square is, but I think how is a square related to some of the other shapes? So squares also have identical sides, so all 4 sides equal. Opposite sides also parallel to each other. Okay, and angles inside a square are 90 degrees. Now, the diagonals of a square are equal to each other, as in equal in length, but they also bisect each other, again, perfectly, and also at 90 degrees. So the squares are very unique shapes in that it has a lot of very, very special properties, a lot of 90-degree angles too. And another shape that's similar to that we just looked at is the rhombus. Okay, so a rhombus basically is a square that's been pushed over. Okay, and with a rhombus, okay, sorry, I've just sort of missed the corner there, but with a rhombus, if you recall the rhombus, a rhombus has all sides equal as well. Diagonals, they're not equal in length, but they bisect each other, also at 90 degrees as well. Okay.